Alright guys, we are now looking at target 4B, which is determine the appropriate domain of a quadratic function that represents a mathematical or real-world concept. Okay, so before we were looking mostly at vertex, x-intercept, and y-intercept. Now we're going to be looking at domain, increasing, and decreasing. Okay, so again, going back to things we already talked about in KC2, all the way back in KC2. But again, now just looking at them in a real-world situation. Alright. So again, what's domain? The domain is the x value, so how far left to how far right the graph goes. Domain is going to be one of the biggest things that's different in real-world context. Because if you think about, we always said it went forever in both directions. But if you think like a ball being thrown in the air and then landing, it doesn't continue like burrowing into the ground forever. It stops. So in the real world, our domain stops as well. Same thing with range, is how low or high the graph goes. And same thing here. It's not, a ball is not going to go down forever. It's going to hit the ground and stop. So in real world context, our domain and our range are a little different. Extrema is just another fancy word for max and min, which we've looked at. And then increasing and decreasing, interval from left to right, when the function values get bigger, so it's like going uphill. You can start slow and start increasing faster, or you can start increasing fast and slow down. Same thing with decreasing, again, left to right, you're going downhill. You can start going down fast and slow down, or you can start going down slow and pick up speed later on. All right. So let's look at just an example of no context first, before we look at when we have context. So again, our extrema is just our vertex. Is really what it's asking here for. It's just a fancy way of saying it. So this one has a max. And that point looks to be about -1/8. Okay. Our range. Remember, range is low to high, or bottom to top. Okay? So our range, my lowest is going down forever, -infinity. My highest is my top point, 8. Domain. Remember, domain is left to right. Okay, so all the way left, well, this is going to keep going down to the left forever, -infinity. It's going to keep going down and to the right forever to infinity. Right? I can pick any x value, and I can find a point on that graph for that x value. All right, so then increasing. Again, increasing is going uphill. Okay, so I'm going up the hill here. I'm starting on the left side of my graph. So I'm starting at -infinity. And I stop here at -1. Okay, so -infinity to -1. Decreasing, going downhill. I'm dropping here. Again, I started at -1. It's like going downhill first. And I decrease forever to the right, which is positive infinity. Remember, these are positive numbers, negative numbers. So -1 to infinity. Again, this is positive because it's on the right. This is negative because it's on the left. All right, let's go ahead and look at the next page. Now it's the graph. Okay, we're going to look at domain, range, all those things. All right, looking at our first graph, we have the t-shirt price versus how much money I make. Both are dollars, so this is our X value is price, and our Y value is revenue. Revenue is just a fancy word for profit. Okay, so it's how much money you're making versus how much you're selling your shirt for. Okay? So determine the interval where the seller earns revenue. Okay? So I only am earning something if I have positive numbers. Okay? Okay. And this is really representing the domain. Okay, domain or the interval where I earn money. Okay, well, if you notice, I start earning money right around here. I'm not earning money at 0, but at like 1 penny I do. So we just say, okay, it starts at 0, but it's not really including 0. Okay, this parentheses means I'm not including 0. Kind of like the less than or equal to. Greater than, equal to. So I'm in the positive, still positive, really positive, decreasing but still positive. Right here at 30 is where I hit 0, and after that, I'm going to be negative money. So the only place where I have positive, where I'm earning money, is between 0 and 30. Determine the interval where the revenue is increasing. Well, if we look here, this is kind of where it flips, right, going up. So it starts at 0, and it's going to stop increasing, going uphill at 15. Determine where the interval where the revenue is decreasing. Starts here, goes down. So 15 to 30 is my interval where it's decreasing. At what price does the seller make the most revenue? Well, again, that's just my maximum point. The price, though, is $15. Alright, let's look at our next problem like this. So, Amit, I don't know how to say that name, is a driver on the swim team. Today, he is practicing by jumping off a 14-foot platform into the pool. His height in feet above the water is modeled by the graph on the right, where X is the time in seconds after he leaves the platform. So again, it's telling me X is time, and the Y is, again, his height. Right, the time versus height. How long will it take Amit to reach the water? Well, again, where do I start jumping versus where do I stop jumping? Okay. Well, I hit the water here. Okay. I hit the water here. I'm going at like 0.9 seconds to reach the water. Where does he start his dive? Well, I start things at 0 seconds. Okay. And go 0. I'll put this again. Where does he reach the water? That's height equals 0. We're kind of always looking at those important points. Where X is 0, or Y is 0, or where it's the highest or the lowest. Okay. So this is where my time is 0. Oh, he's at 14 feet above water. Okay. In real world context, domain really represents start instead of left to right. Okay? So but it's always time. So I start at 0 seconds and I stop at 0.9 seconds. Okay? We will pretty much always start for these ones at 0 because you can't think about what was happening -2 seconds before you started. You might have been doing something completely different. Okay? So we always start at 0 and go to when it lands, when it hits the water, whatever our context might be. All right, let's look at these ones. Find the domain of an equation. So number 1 says a T-shirt is launched during the school assembly. The path of the shirt is modeled by the function f of t equals -16t squared plus 32t. Find the domain of the function. Okay. I'm going to write our steps in. Our first step is to graph on a calculator. Okay, so let's do that. Open a new document. Sorry, no, I don't. And I'm going to do number 2, add graph. So I'm going to type this in exactly how it is. -16, we cannot type x's in. So I'm going to put that here. Change e to x. Okay, so this is another time where our calculators are stupid. They don't understand the variable t. They only understand the variable x. Okay. So -16x squared plus 32x. So my graph is going to look something like this. Again, this is a T-shirt being launched. So it gets launched, it goes way up in the air somewhere over here. I don't know what that is. And then it comes back down and lands here. Again, what is the domain of this function? Well, where does it start to where does it stop? So again, it always starts at time of 0. And then 3, it's going to stop when something stops it. So usually when it hits the ground. So looking at this, starts at 0, it hits the ground right here, right? That's at 1, 2. So starts at 0, stops at 2. So the domain is 0 to 2. Let's look at, there it is. Number 2. A T-shirt is launched during a school assembly. Again, the path of the shirt is modeled by the function f of t equals -16t squared plus 48t. Find the domain of the function. So again, I'm going to open a new document. Not going to save. And I'm going to add a graph. So I have -16, again, x, not t, squared plus 48x. No t. Hit enter. Again, this shirt goes up and then comes landing back down. So again, find the domain of the function. Again, it always starts at 0. When does it land? 1, 2, over 3. So my domain of this function is 0 to 3. Alright, that is it. Go ahead and work on target B activity.